Confronting a 4-year master's program or a technical new skill often triggers a subtle paralysis. The volume of unknowns creates a wall of intimidation. We usually make this harder on ourselves by carrying the baggage of our own ego. We try to apply our past assumptions to a space where they do not belong, and that friction slows down the learning process. To learn rapidly, you have to drop the baggage. You need to approach the subject as if it were a completely different world, and you were a visitor to tune down for the first time. Think of the character PK from the 2014 film. He arrives on Earth without a single reference point for human behavior. Notice his wide, unblinking expression. He operates as a pure observer, absorbing his surroundings with a completely blank slate. Operating without these built-in assumptions allows for the intake of raw data without the interference of existing bias. When you enter a new environment, your first job is to resist the urge to participate. Stand at the edge and silently observe. Take a crowded street market like this one. To an outsider, it looks like overwhelming noise. But if you watch passively, you start catching the underlying rhythms: who moves where, how the vendors interact, and the hidden rules governing the space. Operating with zero reference points removes the cognitive filter. You accept incoming data exactly as it is presented. This is exactly where adults normally struggle. They hunt for familiar footholds in a subject that doesn't have any, and when they come up empty, they get frustrated. By treating the subject as an alien landscape, you remove that emotional weight. The daunting task stops being a test of your intelligence and simply becomes an environment waiting to be mapped. This method of passive observation mirrors exactly how artificial intelligence learns a new subject. Before a machine can perform a task, it requires a vast quantity of raw variables. A neural network analyzes thousands of examples to identify underlying statistical regularities. This maps directly to a student's research phase. As you absorb raw data, your brain begins to naturally organize the noise into rough, recognizable clusters of information. Then comes Output 1.0, your first clumsy attempt at executing the skill. Because the neural pathways are still forming, that first output is mathematically guaranteed to be flawed. Initial failure is a mathematical necessity of the calibration process. Generating these error-prone outputs provides the system the feedback required to adjust its internal weights. The bumbling beginner is essentially a high-functioning algorithm progressing through its necessary calibration phase. Every flawed attempt feeds new data back into your brain. You adjust the parameters, tighten the loop, and try again. Over time, the errors shrink. You reach a moment of alignment, where your behavior begins to seamlessly mirror the successful patterns of the experts you initially observed. That once terrifying environment is now your territory. You move through the space with speed, precision, and complete confidence. True mastery is reserved for those who have the humility to walk into a room and be the most clueless person there at the start. So whatever that next big challenge is, a new job, a difficult degree, or a complex physical skill, drop your earthly assumptions. Treat it like a brand new planet and start exploring.